So we'll start horizontal separator sizing. So how to size it? Okay. Uh, Initially, we'll assume your separator is 50% filled. Okay. This is separator inlet. This is gas outlet. This is liquid outlet. Okay. And gas, oil plus water, and you are using 50% filled. Okay. Uh, we have to calculate seam to seam length. Dia effective length, and we are assuming dm equals 100 micrometer. Okay, and separator is 50% fill. Okay, already I told 50% fill. So one formula is there, DLEF 420. This digit also very unique. You can remember IPC 420, right? So you can remember TZQ gas P into rho G rho L minus rho G CD dm okay. So this will be standard formula for gas capacity. Okay, you should remember this is gas capacity. So we have to calculate based on gas capacity, based on liquid capacity. So presently I am focusing on gas capacity. Okay, learn how to do it. So D is the vessel internal. So lots of units will be there. So D is the vessel internal area. Vessel internal area. Okay, vessel not external, because metal will be thickness will be certain thickness will be there. So you are taking internal area. So internal, not area. This is called dia, and this is inch. So you should remember this one. L effective length of the vessel where separation occurs. So vessel can be, let's say, 10 meter long, but actual separation length will be lower. Okay, because of certain other fittings will be there, so actual separation will be lower, and this unit is feet. Okay, this unit is feet. Okay, effective length of vessel, and T operating temperature. Okay, inside separator what is the temperature? So that temperature. P again operating pressure. Okay, Z your gas compressivity factor. Okay, so in my problem normally I take 0.84 compressive factor. It may be different also, you can find from chart. Many cases I will be giving the value Z, so you may not need to remember, but you should know how to find the value. Okay, and QG gas flow rate. So gas flow rate will be MMSCFD, million standard cubic feet per day. Okay, then rho G, rho L. Okay, rho L is a density of liquid density. This is pound cubic feet, and rho gas again same. Okay, pound per cubic feet, and dm is your micron particle diameter, micrometer or micron, right? And CD discharge coefficient, sorry, drag coefficient. Okay, you should remember the units. Drag coefficient is the ratio, so it will not have any unit, but density will have a unit, pound per cubic feet. Your gas flow rate, your pressure, your temperature, your Z, your effective length. So all the all are having different units actually. You see the D and LEF inch and feet is multiplied, so not same unit, and again another DM is there, micrometer. So lengths are in different unit itself in the same problem. Okay, so you should remember. Now first you convert area of gas, AG. Okay, what is the area of gas flow? So if you see this one, okay, so then a half of this area by 4 d square, so total cross sectional area divided by 2, that is 50% field, that is why it is coming half. Okay, now half into pi by 4 into d by 12 square, you are converting into feet. Okay, so this will be giving d square divided by 367. Okay, now gas flow rate, you have to convert into cubic feet per second, but your data is given SCF. Okay, so Qg into 10 into SCF SCF into day 24 into HR 3600 second, then 14.7, then P into TZ by 520. So this is a conversion. Okay, so finally you are getting 0.327 TZ P Q G. So from standard condition you are converting to operating condition. Okay, so velocity of gas, gas velocity. So gas velocity will be Vg Q by Ag. Okay, so Q, how much you got? 0.327, not 327, 0.327 TZQG by P divided by d square 367. So this will be giving 120 TZQG by P d square. Okay, gas velocity you got this one. Now residence time Tg equals effective length divided by gas velocity. You see the unit effective length in feet, and Vg also feet per second, then finally you are getting second, feet by feet cancel, so you are getting second. Okay, so L effective, and Vg value you can put 120 into TZQ P d square. Okay, and time required liquid droplet to fall. So gas, how much time it is taking, and time required to gas liquid fall, time to droplet to fall droplet. Okay, you say from top it is falling down on the liquid surface. T d by 2, this total circular area divided by 2, that amount of falling, we are assuming that particle is on the top and is falling. Okay, d by 2 divided by Vt, terminal velocity. Okay, that velocity it is getting, right. So now Tg and Td, if we equate, we are assuming that residence time equal to droplet falling time. So same amount of time it is taking gas going out and liquid falling down. Okay, so this will give TD, what is TD? L effective 120 into TZ Q P D square equals D divided by 2 into VT. VT, what is VT? VT previously you have seen 0. 0119 rho g by rho L minus rho g CD by dm, not here, here, power half. Okay. So finally this will be giving the formula. If you equate balance from left side right side the things, then you will get D L effective equals 420 T Z Q G P rho G rho L minus rho G C D by D M power half. Here. Okay, I think I should not put this brace, I will put other. Okay. So this way you are deriving gas capacity equation. So the constant term remembering easy, I said already, IPC 420 you can remember, right? TZQG rho gas divided by rho L minus rho G CD dm power half. Okay. So in exam I may not give directly formula based thing, I may give like step wise. Okay, what is the gas velocity of this one, what is the fluid velocity this one. So actually step by step I can ask you to calculate. So if you want to apply directly, then again finally you have to move to the step by step. Okay, instead of asking directly final question, I'll be asking step by step. Okay, then maybe you can remember for final equation, or you can remember the step by step. So better it is suggested to remember steps. Okay, final equation also you can remember, there is no issue, but steps must be remembered. Now okay, so we said like 50% gas and 50% liquid is there inside our separator. So retention time will be calculated here, liquid retention time. So here D square L effective length, this is the formula actually, TR QL liquid coming 0.7, this is the formula we will derive. Okay, so liquid flow rate, liquid flow rate BPD, capital BPD, BD, whatever you want to write you can write, and TR retention time, this will be in minute. Okay, and D already you know the diameter, L is effective length, and unit is different. Okay, so to derive this one, first take T volume per flow rate. Okay, volume cubic feet, flow rate. Okay, we know the time because volume per flow rate, right? So we can get how much time it is remaining inside fluid. So volume equals half pi d square by 2 L effective. So volume will be like how much fluid is there. So that is pi by pi d square 4 total volume divided by 2 into L effective length. Okay, so that is your volume, and so pi d square 2 into 4 into 144, because you are converting unit, small capital D to small d, and L effective length you are in feet. So it will be coming 2.73 into 10 power minus 3 d square L LEFF. Okay. no. 2.73 10 power minus 3 d square LEFF. Okay. Now flow rate, Q liquid flow rate in BPD equals QL, this is cubic feet, QL Q, wait, what is the unit? QL in BPD, Q in cubic feet a second. Okay. So flow rate Q in QL in BPD, Q in wait. So flow rate QL in BPD. So Q equals QL into 5.61 cubic feet barrel, BBL or barrel, you can write full, day 24 into hour 3600 by a second. So you are getting 42.0 d square L effective. You are getting 6.49 into 10 power minus 5 QL. Okay, QL is cubic feet. Now T equals 42. Now from beginning of this right. Now T equals volume divided by Q. So this will be giving 2.73 10 power minus 3 d square L effective divided by QL. QL means 6.49 into 10 power minus 5 QL. So this will give finally d square L effective equals TR DL 0.7. TRQL in 0.7. So flow rate and retention time, separator diameter and effective length is related like this. Okay, this is called liquid capacity equation. This is called liquid capacity equation. Okay, seam to seam length LSS and slenderness ratio. Okay, LSS by D. Now LSS is related to L effective. This is some empirical relationship, D by 12 for gas capacity. Equals 4 by 3 LEF, any one you can use for liquid capacity. Okay, any one you can use based on your gas capacity, liquid capacity. Yeah, and for liquid okay, so LSS divided by D must be greater than equals 1. Okay, for horizontal separator, for most common LSS by D will be 3 to 4, most common. Okay, so length will be 3 to 4 times than diameter. So if I ask you to calculate seam to seam length, defective length or diameter, so you have to follow certain steps. So first you have to calculate D and LEFF, okay, diameter and effective length, and then to do this one you have to use the formula DLEFF equals 420, and you have the formula. Okay, then calculate D square TRQL 0.7 from liquid capacity. First you calculate from gas capacity, then you calculate from liquid capacity. Okay. Then you calculate LSS, seam to seam length. Okay. So, we will show how these steps will be going on, and then slenderness ratio you have to calculate. Slenderness ratio, LSS by D, like you keep 3 to 4 and you select your values for diameter, total length, effective length and seam to seam length. Okay. So, this will be the procedure. So, it is looking like very simple, but it can be very long question also. Let us see. Yeah, so this problem actually is given in your Arnold and Morris book. So, a two-phase separator 50% gas filled, and this can be different percentage also, but for simplicity I am using only 50%. Okay. Gas flow rate 10 mmSCFD, oil flow rate 2000 barrel per day, 40 degree API. So, this means light oil. The specific gravity of gas 0.6, operating pressure 1000 psi, temperature 60 degree Fahrenheit, droplet 140 micron, LSS, D, LEFF you have to calculate, and these two values actually CD can be iteratively calculated and Z value can be taken from your chart. But presently for simplicity I am just asking you just fix it and try to calculate. Okay. So, first you have to calculate D effective length, LEFF. Okay. So, the formula TZ Q by P rho G rho L minus rho G. Here also you will not do any mistake because rho L high density, high gravity will be there. So, rho L minus rho G, otherwise it will create a negative symbol. Okay. And then CD by DM, and whole thing will be half. Okay. And one constant I forgot. Okay. Now, you put all the data 420 T 520, actually 460 T and F conversion 460 degree Fahrenheit equals Rankine, right. So, you have to add this value directly 420 plus okay, T value means 460 plus 60 into Z value I have given 0.84, QG already given directly 10, okay, and P value already given 1000 psi. Okay. So, we got this one. Next is rho G value also given. No, rho G, rho L you have to calculate actually. Rho G equals 2.7 SP TZ. This is the formula. So, you can calculate 2.7, S means 0.6, specific this one S they are writing. P is your pressure, okay, 1000, T 520 already 460 plus 60 plus Z 0.84. So, this is giving 3.71, and whatever rho L is 62.4, 141.5 divided by 131.5 divided by plus 40 means 40 degree API already given. Okay. So, this is giving 1.5 pound per cubic feet. Okay. So, those values I will be putting here. So, 3.71 rho L value I have got 51.5 minus 3.71 into CD value 0.851, 140 micron is given there in problem, okay, and power is half. So, finally, we are getting 55.04, okay, D and LEFF multiplication. Now, you have to calculate based on liquid capacity. This is from gas capacity. Okay, first you have to calculate gas capacity one, then you have to go to liquid capacity. Liquid capacity formula is that d square LEFF TR QL divided by 0.7. Okay, now QL value you know, TR you have to assume 1, 2, 3. Okay, so how to here? So TR value you take 1, 2, 3. Okay, now you calculate gas capacity LEF. Okay, first you take D value. D you can assume let us say 30, 36, 42. So 30, 36, 42. Okay, now from D then you calculate gas capacity LEFF from gas capacity. Okay, from gas capacity LEFF if you calculate from here using this formula you can calculate, because D value already got, so you can calculate LEFF. Okay, so for then you fill the table. Okay, for 1 minute, 2 minutes, 3 minutes. So for gas capacity anyway T term is not there, so just directly you can calculate, you can fill LEFF. Okay, now liquid capacity LEFF from liquid capacity can you calculate. Okay, then you can calculate LESS, seam to seam length. Okay, then once you get seam to seam length, then you can calculate slenderness ratio LESS divided by D. Okay, seam to seam length calculate. Now when you get your LSS divided by D or slenderness ratio 3 to 4, so that value you have to take. Okay, so first you have to assume different retention time 1, 2, 3, 4, then you take different D values. Okay, now you calculate LEFF for gas, LEFF for liquid capacity, gas capacity, then you can calculate that seam to seam length, then slenderness ratio LSS by D. From there you calculate slenderness ratio, so you try to maintain this. You try to maintain slenderness ratio about 3 to 4. Okay, and because it is 40° API, so you can take directly TR equals 1. Okay, if I do not give any criteria, then maybe you have to calculate 1 or 2 TR. If I say okay, take only TR1, then take TR1 and you calculate. Okay, but if in many cases I keep it open to student, take a suitable value. So in that case you can justify I am taking 1 because it is 40° API. Okay, some author says 40° API means TR1 is okay. It's low light oil, so low TR value. So for that I am calculating. Okay, so when we are solving problem, you see how much marks is given. If marks is 5, then maybe it will be one page solution. So in that case maybe TR1 is okay. But if marks is 20, so in that case I will assume that you will be calculating 1, 2, 3 also, you will be calculating several, and it will be longer question. Right? If 5 marks question means you have in one page solution when you are giving, it will be more simplified form. So you can justify like I am taking TR1 because of this reason, and I am not calculating so many data because of this reason, and I am making simplified. But if it is 20, that means you have to give detailed solution. Okay, so and again when you are solving, you give step by steps. So in this case the diameter they found 36 into 10 feet, 36 length and 10 feet diameter, 36 inch diameter and 10 feet length. Okay, inch 36 means 3 feet diameter and 10 feet length. Okay, seam to seam. Okay, so if we want to go to solve vertical separator issues, so first you have to remember the formula d square 5040 T Z Q P rho G rho L minus rho G C D dm okay. Now let's start deriving this one. Okay, Vt formula you have seen 0.011 constant, rho L minus rho G into CD dm power half. Okay, gas velocity. So vertical separator, first you draw one inlet is there and gas liquid is going down, gas is there, liquid is out. Okay, so gas velocity Vg equals Q by Ag. Okay, so Q by Ag means pi by 4 d by 12 square. D means diameter, right? So you are converting unit also, you are making feet. So it is making Q d square by 183. They calculated like this. Okay, A in feet, Q in feet Q per second. Okay, now Q formula for gas, Qg into 10 power 6 SCF as MMSCF into day 24 into hour 3600 into 14.7, because from standard condition to operating condition you are converting, that's why this 14.7 coming, divided P T Z by 520. Okay, we are assuming same 60 degree temperature. So this will be giving 0.327 TZQ by P. Now Vg equals 0.327 TZQ by P divided by D square. Okay, 183 then, right? Okay, so now this is giving 60 TZQ P D square. So Vt equals Vg. So this implies 0.0119 rho L minus rho G by rho G dm CD half equals 60 TZQ P D square. So this gives D square equals 5040 TZQ by P rho G by rho L minus rho G CD by dm half. Okay, so this is the formula for gas capacity equation for vertical separator. Okay, for liquid capacity for horizontal separator, your formula is d square H equals TRQL divided by 0.12. Okay, so this is your separator. Okay, so T in second is volume divided by QL. This is BPD. Okay, volume in cubic feet. So it will be giving volume is pi by 4 d square H by 12 QL. Okay, what is D? D is this one, H means this one. Okay, so total volume we are calculating pi by 4 d square H by Q by L. Okay, now Q again Q liquid into 5.61 cubic feet barrel into day per 24 into hour 3600 So it will be giving 6.49 10 power minus 5 QL. Okay. So TR in minute. So now TR equals pi by 4 D by 12 square H by 12 QL 6.49 into 10 power minus 5 QL. So that will be giving D square H equals TR QL divided by 0.12. Okay. So this is a formula for liquid capacity equation, and for seam to seam length LSS equals H plus 76 by 12, or you can use any one formula, H plus D plus 40 divided by 12. Okay. Slenderness ratio you should keep less than 4. LSS by D less than 4, 4 or less. Okay. Most common 3 to 4. Most common 3 to 4. Okay. Okay. Take the similar problem as horizontal separator. This is for vertical. Okay. So vertical separator, same flow rate you are taking 10 mmSCF, SCFD. Your gas flow rate, your liquid flow rate equals 2000 BPD. Okay. Z value 0.84, your CD value 0.851. Okay. So all the parameter whatever you have taken for horizontal separator, same parameter you take for vertical separator. Now you will try to calculate for D LSS slenderness ratio. Okay. Operating pressure is given 1000 psi, and temperature is 60° Fahrenheit, 60° Fahrenheit, and your diameter 140 as it is, whatever micrometer or micron. So initially assume CD value 0.851. Okay, already written. Okay. Viscosity is 0.013 Cp as viscosity. So rho g 2.7 into 0.6 Sp, P means 1000. Okay. Temperature 520, and your Z value 0.84. So formula is that 2.7 SPTZ. Okay, is rho g. So this is a formula. Okay, dm is given on 40. So Vt equals 0.0119 51.5 minus 3.71. In previous question, if you see horizontal separator, we have converted already. So same thing I am putting here. I am not calculating again. 3.71, 140 your micron diameter given, 8. CD value is given 0.851. Okay, and then it is power half. So gas capacity equation, D square equals 5040 TZQ P rho G rho L minus rho G CD by dm half. All right. So this value will be coming D 21.8 inch. Okay, directly we got diameter. Now you have to go to liquid capacity. Liquid capacity will give like D square H equals TR retention time Q liquid 0.12. So here the constant term is changed, actually 0.12. Previously it was 0.7 in your horizontal separator. Okay. So again you try to calculate TR, you take 1, 2, 3, okay, different retention time, and then you can calculate D inch, okay, D inch already you have, H you calculate, LSS fit, then 12 LSS divided by small d or LSS divided by capital D. Okay. So if you can calculate, then actually diameter we are getting 8 and slenderness ratio equals 3.2. Okay. So around 3 slenderness ratio means your design is okay. Okay. So I am not showing all the values, so it is book solved problem. So please go through the book, because there are several calculations they have done. For exam purpose, I cannot ask you to do all the calculation manual work. I will ask maybe to calculate 1 or 2 point and you show these things. Okay. Because my intention will be to know that you understood things and you know the steps how to solve, how to design a separator, not to do manual calculation too many things. Okay. So thank you very much for this lecture.